833, rewrite the following expressions with at most one radical. Okay, so with working with completing the square and working with quadratic formula, we're going to have radicals in our answers, and so we need to know how to add, subtract, and simplify them. We've talked a little bit about it, but here's some more problems. So for A, when we take root 3 times root x, because they're both under the square root, this is the same thing as 3x. Okay. In B, what we have here is I'm multiplying two radicals and I have some numbers outside. So what I always like to say is you can multiply the things that are the same. So we can take 2 times x, that gives us 2x. We can take 3 times 27, and when you take 3 times 27 you get 81. So then once you get the square root of 81, everybody knows that's a perfect square. So now we get 2x times 9. And then 9 times 2 is 18x, and that is simplified. Alright, so now in this problem we are multiplying these. So you can do this a couple different ways. Just to be consistent with what the book's doing, we can actually create a area model, right? And so we can have root 7 and then minus root 5 here. And then we can have root 7 here, and we can have root 5 along the bottom. Square root of 7 times the square root of 7 is the square root of 49, which we know the square root of 49 is 7. Negative root 5 times the square root of 7 is negative square root 35. Root 7 times the square root of 35 is the square root of 35. And then negative square root 5 times square root 5 is negative square root 25. But what do we know the square root of 5 is? 25 is 5, so this is negative 5. Alright, so now at this point, once we have it in our area model, we just combine like terms, right? So if you have negative square root 35 and positive square root 35, these cancel. And then 7 minus 5 equals what? 2. So this simplifies to 2, which you wouldn't expect. But if you notice, these are a difference of 2 squares. So when you have the difference of 2 squares, usually they simplify quite a bit.